A retry is not a strategy, retry is a decision. And if your system retries without understanding what failed, it is not becoming more reliable, it is becoming problematic, can duplicate side effects, hide permission problems, waste tokens, make logs harder to read, and it can turn over clear failure into 5 confusing failures. In Module 2, we built the routing layer. The rule was response state controls the loop. Now, in this lesson, we add the next layer, safe control. Routing answers the questions. What state did Claude return? Safe control answers the next question. What should the application safely do now? The answer is not always retry. A good system classifies the failures first. Then it chooses the smallest safe control action. That is the whole lesson. Classify first, then continue, retry, stop, or escalate. There are 4 basic control actions. First, continue. Continue means the system has the information it needs and should move to the next step. Second, retry. Retry means the same operation was trying again under controlled conditions. The third, stop. Stop means the loop should end safely. Fourth, escalate. Escalate means the system needs a human, authorization, clarification, or a policy workflow. The key rule is simple. Classify the failure before choosing the action. If you skip classification, every error starts to look like a retry problem. That is exactly the exam trap. And it is exactly the production failure we want to avoid. Now let us define the retry gate. A retry is appropriate only when 5 checks pass. First, the error class is retried. Second, the action is idempotent. Third, the attempt count is bounded. Fourth, the new attempt changes something useful. Fifth, logs preserve what happened. If any of these checks failed, retry is probably not the first lever. More attempts without new information are not control. If the system sends the same bad request 5 times, that is just a louder failure. A useful retry does one of 2 things. It waits out a transient condition, or it adds specific feedback that can change the next result. For example, a temporary overload can be retriable. A timeout can be retriable. A rate limit can be retriable when the system respects the retry timing and stays inside its configured boundaries. But a missing customer identifier is not fixed by trying again. And a permission failure is also not fixed by asking the model to try again. A policy boundary also is not fixed by blindly retrying. An unknown response state is not fixed by looping. That is the distinction. Now separate the failures that should not be blindly retried. Missing information needs clarification or source information. Permission failure needs authorization or escalation. Policy boundaries need a policy pass. Ambiguity needs clarification or review. Unsafe side effect need a stronger guard. Unknown response state needs inspection. Context failure needs context management. Not every failure is a retry problem. Many failures are boundary problems. This is where many destructors come from. An answer that says add retries may sound resilient, practical and production ready, but if the failure class is wrong, the decision becomes less safe. The safer answer preserves context and routes to the correct boundary. Now let us talk about idempotency. Idempotency is a retry boundary. Same operations are naturally safer to repeat. Reading a customer profile, checking a job status, fetching a public document, looking at a cached result. If you repeat those operations, you usually do not create dangerous side effects, but other operations are not safe to repeat blindly. Charging a card, issuing a refund, sending a final customer email, deleting a record, creating a new account, submitting an approval. If the side effects cannot safely repeat, retry needs a stronger boundary. That might be an idempotency key, as a stored operation identifier, a precondition check, or a human approval set. The important point is this: retry safety belongs in the control decision, not in wishful prompting wording. You cannot prompt your way out of unsafe side effect. You need a boundary. Now let us talk about partial success. Partial success still counts. If one tool succeeded and another tool failed, do not throw away the successful part and do not pretend the whole workflow succeeded. Preserve what worked. Name what failed. Log what was attempted. Enough recovery context for the next controller, human or workflow to choose correctly. Generic failure hides the next correct action. A useful failure record tells the system what kind of decision is needed next. Retry, alternative path, continue with partial results, escalate, stop safety. That is why structured errors. Context matters. It lets the system choose the next action instead of collapsing every problem into something went wrong. Now here is the ranking drill. A timeout can be retriable if the retry is bounded and idempotent. A rate limit can be retriable if the system respects the retry timing and doesn't amplify the load. A validation failure can be retriable when the next attempt includes specific validation feedback. A permission failure should escalate or request authorization. Missing data should ask for source information or route to review. A policy boundary should move to the policy path. And unsafe side effect should require a stronger guard. An unknown state should be inspected instead of looped. The point is not to memorize one answer. The point is to match the control action to the failure class. That is the same answer ranking Muscle from the model 1.2. And it is the same decision artifact Muscle from model 1.3. Now let us open the course download pack and look at the retry decision table. This table is a durable reference. Start with the transient failures, temporary overload, timeout, rate limit, short service interruption. These can be retriable when the retry is bounded, idempotent, and respected the available retry signals. Now look at validation failure. Validation failure can be retriable only when the feedback is specific. If the schema says a require fields is missing, the next attempt must add the missing field or ask for it. If the format is invalid, the next attempt must include the exact correction. Now look at the missing source information. This is not a blind retry problem. The system needs the missing source clarifications, retrieval, or review. Now look at the permission failure. The correct path is authorization or escalation, not another model call with stronger wording. Now look at the policy boundaries. The correct path is the policy workflow, not a retry loop. And now look at the ambiguity. The system should clarify or route to review. Ambiguity is not fixed by repeating the same request. Now look at unknown state. Unknown state should be preserved, logged, and inspected. Do not loop on the state your code does not understand. Now open the request routing cheat sheet. This gives you the control checklist. Before retrying, ask, what failed? Is the failure class retriable? Is the action idempotent? Is the attempt count bounded? Will the next attempt change anything useful? What must be logged? And should we do escalation instead? The checklist is the difference between control and noise. Now connect this to the exam lens. The exam will often give you a system that fails in a way that sounds retriable at first. The answer choice may say, add atomic retries. That sounds reasonable, but you must ask, what kind of failure is this? If the system timeouted during the safe read, bounded retry may be correct. If the system was denied permission, retry is wrong. If the system lacks required information, retry is also wrong. If the system may duplicate a side effect, retry is dangerous. If the system entered an unknown response state, retry is guessing. So, your exam ranking loop is classify the failure, check the idempotency, check whether the next attempt changes anything, check whether the loop has bounds. Then choose a continue, retry, stop, or escalate. That is a safe control. Now your logs must prove the decision. For every failure, preserve the response identifier, the stop reason, the error class, the tool name, if there was a tool, the safe input summary, the attempt count, and the next action, and the escalation reason, if escalation is chosen. Within those logs, the system becomes debuggable. Without those logs, retry hides the evidences. Retry without classification is just a failure repetition. Use retry decision table when practice the exam questions. When you miss a question, do not only write down the correct answer, write down the failure class, write down the safe control action, and write down why the tempting retry answer was wrong. This is one of the core product architecture habits in the course. In Module 2.4, we apply the safe control layer to observability and logging. Because once the system can classify and control failure, the next question is, can you prove what happened? Classify first, then continue, retry, stop, or escalate.